think so far this conference has been great. A lot of good sessions, and I know it's always tough on the third day here when you're running near the end of the sessions here. So I appreciate everybody sticking out the end of the conference here, and we're going to spend about an hour today talking about ways to effectively hook up the Wireshark product. And so what we're going to be looking at doing here is talking about different ways of network monitoring and just some of the basics. You got your laptop, you have the product, download it, and it's on your laptop and you're ready to go. So now I want to start analyzing and troubleshooting, and what do I need to do to get that working and connected up to my network. So we're going to be talking about access technology. I really want to try to keep this as open as possible. So throughout the presentation, you have any questions, we're also going to set up some equipment and go over a couple of examples. And so let's try to make this as productive as possible for everybody. And if you do are looking for anything in particular, just shout out the question, and we'll address it. And then if you need to get more detail, we can always talk a little more after the presentation. But this is my fancy scrolling to keep everybody, make sure everybody's awake here at the end of the day, since we don't have a coffee pot here. But I'm from Network Critical. My name is Chris Bahari, and we have a couple other folks here as well. Sam Battaglia is helping out. He's our technical manager, and he's here helping out set up some of the stuff. Also Mark Mannion, who's our West Coast rep. So if you have any questions, we can get into that in a little more detail. And Network Critical, we focus on access technology, and that's what we're going to be talking about today, and seeing why this is a important piece of the network that sometimes is forgotten. And so when you start looking at the basics of network monitoring, this show is obviously a Wireshark focused show, so we're focusing on the analysis side, and looking at the applications of once you get the data, what do you have to do with decoding, or how do I solve my problem? And I actually want to bring it back a little and start looking at more of the foundation. So when I look at the basics of network monitoring, I like to talk about really three just fundamental basics. One is you need to somehow get access to the data on your network. Then you're going to have to physically capture your traffic and then analyze it. And today, and over these last couple of days, the focus has been working with Wireshark. But there's a lot of different applications out in the marketplace that people utilize to analyze their network. So obviously we've been focused on network analysis and protocol analysis. But when you look at the analysis side of the network, there could be a lot of different groups within your enterprise networks that need to analyze the data. So if you have voice over IP recorders, you need to record. You get the message saying your phone call is going to be recorded for training purposes. Well, how do I get focused on and actually capturing that data? So when you look at analysis, there's a lot of pieces to it. Lawful interception, maybe if you're dealing with telecommunication companies, data leakage, security. And so this is a piece that is very known in the marketplace. A lot of people focus on the analysis side. They look at what applications and tools they're going to be using. And obviously over the last couple of days, it's been focused on the Wireshark analysis side. So again, when you start looking at that, then people also start looking at capturing the data. And I know Solera Networks did a session which was focused on physically capturing the data when it comes off the network. So again, when you start looking at the foundation of the basics of networking, you also have to look at the bottom piece, which is access. And when you look at access, it's really the foundation of how do I get the data physically off my network. Where's the problem within my network, and why is access so important? it's like I always like to use the analogy of someone. I kind of stole part of it from some commercials, but you're on the cell phone, you call up your doctor, and you're talking to your doctor, and you start losing connections. You tell him half the problems you're having. He could be your a specialist, and you're giving him only half the information. So how is it going to give you a good answer on how to solve the problem if you didn't provide him all the data from your network? So this really comes down to focusing on the foundation of when you're starting to do any type of network monitoring or analysis. So let's get into a couple issues, and how do you physically, how am I going to get, I have the software on my laptop, you're going to put on a server, how am I going to connect up to the network? Now, there's a couple ways of doing this, and gentleman in the back, you mentioned, I believe Laura mentioned hubbing it up, or
hubbing out is what
hubbing out. So, there's a couple different ways, and I'm going to talk about how to physically connect up. Has people used hubs to connect up their Wireshark analyzers before in the past? And how about spam ports? Anybody familiar with? I'll get into this in a couple minutes, but just kind of familiar about before you just set up spam ports to collect traffic. How about tapping? Has anybody physically used a tap in the past, or any type of device to go in line and get a copy of traffic before? All right, well, this is the part where you really want to look at how do I physically get the network access. And when you start looking at 10100, it's good to kind of go back a little in history of networking. And when you start looking at network monitoring, when hubs were mainly used in an Ethernet environment, getting access to your network wasn't very difficult when your environment was a shared topology. So, within a Ethernet 10100 environment, and if you had a hub in your network, everybody is getting a copy of the data. It's a collision-based environment. So, a packet gets sent into the hub, and if two people send the traffic at the same time, there's a collision, it gets reset. But what you can do, it makes it very easy to do monitoring, because if you had, let's just say, a small network, you have 10 users on it, and it's a hub, you can plug in your laptop, which has your single Ethernet port on it. You can plug it into the hub, and you can see all the traffic on the hub and start collecting it and start doing your analysis. So you have your access point within a hub. Is any port on your hub. It's a shared topology. So it makes it quite easy to get the data. So now you can, if you have your laptop with your NIC card, you can now capture the data. And now you can start analyzing it with your particular product that you're using. Now, as we started moving forward, it then started getting into Ethernet switching, which started causing some problems. But one thing I'll talk about for a couple minutes on the Ethernet hubs question before we got started was...
my question is, if you want to use a hub in a 100 full duplex environment, does that eliminate the hub as a tap solution, or do you just go in and reconfigure the host and the switch port in your computer to 10 half and then use the hub to do the tap? Okay,
so so if you're using a hub, one of the nice things is you can still find a hub, and sometimes that's a problem of having. But if you do have a hub that you can use in a 10100 environment, you can connect up a hub in between the switch and the device, and what's going to happen is it is going to drop down to half duplex. So you're only going to have the ability to physically do half duplex. You're not going to be able to monitor full duplex traffic. So that's one of the limitations of a hub. But it is easy to use. With most people, I'm assuming if you're using Wireshark, you're generally running on your laptop. So you only physically have one port on your laptop a lot of times to collect data. So the nice thing about a hub, if you're using it, is that you can plug into the hub and you get to see all the traffic. So if you're hooking up your switch port and your server, you're going to see all the traffic flowing, but you're really not going to see the real-time traffic. There's big collisions. Maybe your environment, as you said, your server and your switch are set up at full duplex. So now you're changing everything down, so you're really not getting the full view of what your network is and what the potential problem is. So it's a nice tool to have. It it can work. You're in a bind and you want to use a hub. It's definitely an option. And again, it's assuming that you're in a 10100 environment. If you're in a gigabit environment, there's not a hub available that you can use to physically solve that problem. So when you look at the history, when we started moving to Ethernet switches, the great thing about Ethernet switches is it really helped increase the performance of the network. And because now with a switch, if you have two devices talking to each other, you're not broadcasting that traffic. It's not shared topology. So now if your PC is talking to the server, you're being switched right to the server, and that was great for network performance. But now this causes a problem for how do I physically get access to my traffic for monitoring purposes? And in this particular case, how do I hook up Wireshark to my networks? I want to see what's happening in between my switch. I also want to see what's happening between my server and my PC. So how do I physically get a copy of that traffic? I need that access point so I can capture it and then start analyzing it to see what the problem is. So what the switch manufacturers did is they came out with a mirrored port, either called or was Cisco SPAN switch port analyzer, providing you the ability to physically have a copy of that data. So now what you're doing is you're taking your switch in your live environment, and what you're saying is I want my switch I want to monitor the traffic between my server and a PC. So physically what's going to happen is my SPAN port is going to generate a copy of that traffic and send it to a single port. So this works well when you start looking at Wireshark in terms of the single port aspect. Because again, a lot of times with Wireshark, people are going to be again using a laptop, so you have a single port on it for data collection. So it's important that you have that ability to connect up to your switch. So with spanning, the nice thing is, a lot of times if you bought the managed switch, this is a feature included. So it's a cost included, and it also gives you some benefits to see the internal conversations on the switch. But there's also quite a few limitations when you start looking at spanning your traffic. One thing is if you're going in between let me go back here to the slide. If you want to see the traffic between your server and your switch, and you want to analyze that, as you said, let's say you have a full duplex link. How do you physically do that? Because now you have two ways of traffic that you want to monitor, and depending on your switch ports, that may not be supported where you can actually monitor the full duplex traffic. Another thing with spanning is that you're running into a trouble is that it's physically providing you a copy of data, and it's changing. So you're changing actually sometimes the timing on it. You're not getting the exact timing of your traffic going over span ports. You're also running an issue of decreasing the performance on your network. Now what you're doing is you're taking your live production environment and your backbone of your network, and depending on where you're going in to access data on your network, but now you're physically saying, I want to take a copy of that live traffic that's running on the backbone, and I want to now replicate that out to my span port and run that over my switch. So now you have an issue of switch performance. So am I affecting, am I becoming, instead of becoming part of the solution, am I becoming part of the problem? You're also dealing with dropped packets. So layer 1, layer 2 is dropped. So you're truly not getting 100% visibility into all the traffic on your network. And that's really what we're focused on today is how do I get access to my network and how do I get all the traffic and guarantee that I'm going to see it. Now, again, and I'm not saying that span should never be used because it is it's a nice feature if you have it on your switch, but you also have an issue of it has to be configured. I mean, I've talked to many people where they say they configure the span port and they forgot they configured the span port and they go back in and there's problems on their network, what's going on, and they found out that they left the span port open. And that can become a security risk as well. Now you're copying traffic over. There's also issues just of being able to use it. Maybe, as I mentioned with analysis, there's a lot of different tools out there that you may want to hook up. But what if you're in the VoIP department and I need a span port? Well, now I have to go over to the networking group and ask them to set up a span port. Well, we have that span port set up. It's taken. That's by security. We can't do anything about it. So, there's also a lot of issues sometimes with span ports if there's just a contention. Or sometimes they're not available as well. So, not only are there the, some of the technical limitations of the fact that, traffic is, physically being changed. You're not seeing the exact copy of traffic on the network. If you're working in the, compliance piece of it and you're hooking up a compliance tool, what are the issues there? Packets being dropped. And there's actually a great, I know these presentations are going to be, put up in a disk and I think sent out to everybody or be able to download. But there's a great article written by Tim O'Neill, and it's actually posted on Love My Tool. And it's a great white paper geared towards just talking about spanning, what are the implications, what are some of the technical issues, and why you want to potentially also look at tapping and what are the differences. So it's a great article. It goes into a lot more detail than I've gone into of explaining why you may want to consider it for your particular application and monitoring. So let's talk about the third option. Like I said, you could use a hub. There's some limitations there. You could also look at utilizing span ports on your switch. Another way you can look at connecting up to the network is looking at using a network tap. I know, I think a couple people said they're familiar with it. They've worked with network taps in the past. And what a network tap does, and I kind of hold this up so everybody can kind of see it, but very simply what a network tap does, it physically goes in line to your network. So you want to physically look at the traffic going between your server and your switch. You physically have two cables. You have your server plugged into, in this case, an A port, and then you have your switch plugged into the B port. So now you have a physical connection going between your two devices. And very simply, what a network tap will do for you is it will physically provide you a copy of the traffic flowing between your two devices. Now, there are a couple different types of taps out there, and with a network tap, a standard basic network tap, when you look at the 4 ports on this product here, they're labeled A, B, C, D. You have, as I mentioned, the server plugged into A, and then you have the switch plugged into B. A standard tap, what we'll do is we'll provide a copy of each side of the traffic. So anything going into A will go out C, anything going into B will go out D. So now this can potentially cause an issue when you have a laptop with only a single port, but that is something, I've had people call me up and say, hey, I got your tap here, and it's, I went to go hook it up to my laptop, and I'm getting 2 copies of the traffic. But the purpose of that with a standard network tap is that in a full duplex environment, if you're tapping a 100 megabit link, you have the ability to physically, at 100% utilization, run 100 megabits in each direction. So if you were to put this in a lab environment, run it at 100%, what a tap will do is physically provide a copy of everything flowing from errors. It doesn't matter what's running on the, it doesn't look at the packets, it's not inspecting, we're not, it's a physical layer connection. So a couple important things when you're looking at tapping is that if this device were to lose power, the 2 ports will still allow your live network connections to talk to each other. So if there's a, for whatever reason, power is lost, you have fail-safe technology that allows your 2 network devices still to continue to talk. So the funny thing is it's one of the few products that in the user guide what they're going to tell you to do is power it off and hook up your 2 network devices. And the reason for that is, when you physically connect it up, your 2 devices are going to communicate with no power to the tap. So then when you turn the power onto it, now it starts providing you an exact copy of all the traffic that's physically going back and forth between your two devices. So, it's important that, these aren't, the device isn't meant to capture the data. The device isn't meant to analyze the data. It's meant to, provide you, 100% access to all the traffic and provide you with that copy. So there's a lot of different tapping technologies out there, and one of the things that, especially with Wireshark, is that a lot of people use this as a mobile application. So when you look at a traditional tap, as I mentioned, physically there's two monitoring ports. It's providing you the east to west and the west to east traffic. So generally a basic network tap isn't going to help you out too much when you go try to plug it into your laptop. So there can be some issues with that. And with tapping, there's a couple different terminologies out in the marketplace, but what you can do is get an aggregating tap. So what an aggregating tap will do is it'll take the full duplex traffic. So it'll take the traffic going into A, take the traffic going into B, and it will provide a copy of that, and then it will combine that traffic. It will aggregate it together to a single monitoring port. So now what you can do is you can physically tap your link, and now you can aggregate the traffic to a single monitoring port and send that to your laptop, or send it to your capture engine, which is going to start collecting the data. So it's important when you're looking at, if you go you go hop on eBay and find a network tap and you go buy it, and it comes in and it has only it has two monitoring ports on it. You're only going to see one side of the traffic. So when you're looking at a mobile application with your Wireshark application, you definitely want to start looking at potentially an aggregating tap. Some other technologies, which I'll just briefly talk about. Other things that you can do is you can get into what's called regeneration, where in this case, this tap, you can tap the link, you can aggregate the traffic and have it come out two ports. So you can have your Wireshark connection to port C, and then you can have your intrusion detection system on port D. So with the technology out there today, there's a lot of flexibility of what you can do in terms of gaining access, because it's not just generally the one Wireshark tool that you want to connect up to your network. A lot of times, depending on, especially in enterprises, if you're in the like I said, VoIP group, you have your quality of service products, you have your recording products, you're in security, you have intrusion detection, content management, you have there's just the amount of tools out there, compliancy tools. It's it can be overwhelming. How do you physically get a copy of that traffic to all these tools? So there's what's called replication, where you're physically replicating the traffic out, or some people call it regeneration. And then you also have the ability of monitoring. What if you want to monitor two links and they're an active passive link? So you have traffic flowing actively on one, and then you got a passive backup. What you can also do with aggregation is you could tap those links and aggregate the traffic to a single Wireshark product. So there's really a lot of different types of tapping technology in the marketplace, and this is just an example of taking physically tapping. So again, you're going between your switch and firewall, and let's just say these are 4 10-100 links. So you're physically tapping. If this device were to lose power for whatever reason, someone pulls out the power cord, you're still going to have the ability for, with the power off, all your live networks still going to talk to each other. You're going to lose the capability of monitoring. But once this device is on, now what you're doing in this case, taking 4 10-100 links, aggregating it together to a single port. So now your Wireshark box can actually see 4 links. So there's different types of aggregation where you can take multiple links. Some people want to take tap multiple links and then replicate that traffic out many times. So it's, there's a lot of different ways to do it, and there's a lot of different types of products out there addressing it. One other technology is called a bypass tap, and again, I'm just to introduce you to it. It's really not applicable in the Wireshark arena, but if you're deploying some open source applications and you want to run not just an intrusion detection system, let's say you want to run intrusion prevention. So the difference is very quickly is that in intrusion detection system, it's a sniffing application, just like Wireshark, where it's listen only. And with intrusion prevention, what's actually happening is you want to put your server in line. So you actually want to place your server in between your router and your switch. But you don't want your server, let's say your server, you update or you have to reboot it, you don't want to interrupt your live network because all your e-commerce traffic's running over it. So with a bypass tap, it's a little different. Instead of just providing a copy of data to your monitoring port, it's actually taking the data, brings it in, passes it through your intrusion prevention system, and then back onto the network. And we make sure that this inline appliance intrusion prevention system is alive, and if it, for whatever reason, goes offline, your live network's never affected. So, connecting up the analyzer, a couple things. With your analyzer, utilizing Wireshark, again, most people, nowadays have a copper gigabit Ethernet port on your laptop. So what if you want to physically see what traffic's happening on a fiber link? You can get a fiber tap that converts over to copper. I don't think I have one with me, but again, providing that access. How do I get in between my two switches that are fiber optic connections? You can get into multi-mode, single mode, so physically you can connect up to your network and get a full copy of all the traffic flowing between those two devices. And when you really look at it, these are pretty easy devices to install. We got a couple here, and I mean, essentially, if you wanted to, see the traffic, I think Sam set up, just set up a connection to a Linksys hub, and going in between his laptop. Essentially, you're placing the tap in between. Grab that right now. But so essentially, you take another cable, plug it into. So now between his laptop and his Linksys hub, now we're going to get a copy of all the traffic flowing. And what's nice about looking at taps, it's a physical layer device. We're not dealing with the application layer. We're dealing at the physical layer of the OSI model. So they're also very easy devices to utilize. So now you don't have to worry about, do I go in and set up my spam port, and what if you do something wrong? There's a problem with the network. Question? So it's, it makes it, very easy to get access. And maybe you have some critical points within your network that, you want to have the ability to get in there quickly. You can permanently place these within your network, and when you need to access it, you can. Talking with Mike Panaki, he was saying that what would be great is he was showing a command that automatically dumps data to a hard drive or a server or whatever. And what would be nice is let's take a look at your network when you don't have a problem. Let's collect some historical information. So you can have a tap in place between your switch and your router, and you can have all that traffic going into a PC running Wireshark, and just start dumping that traffic, capture it and store it to a hard drive. So provide you with that permanent access point, and it's really simplifying how you get access, and then also guaranteeing that you're going to see all the traffic on your network, which is important. Because again, a lot of times we focus so much at the application layer and learning the application side, and we forget about building the foundation. A lot of times people will call up. I mean, I've had a situation where dealing with a bank, and they bought 50 analyzers at about $30,000 a pop. So their goal was to go out and physically install these on a span port. So this particular product only had a single interface on it, and they didn't have a way to communicate and manage. So they had to collect the data, plus they had to manage the box with a single interface. They go plug it into a Cisco switch, and when they initially did the test, it was a different iOS version that supported bi-directional communication on the span ports. They found out they didn't have that anywhere in their network. It was just in their lab. So now they're sitting on whatever that is, 50 times 30 grand. Boxes sitting there. Management's not too happy. How are we going to get these devices hooked up to the network? And how are we going to get the data that we need to it? So a lot of times what happens is, a lot of times we forget about the foundation. We forget about starting to build your network and build your network to monitor it. I mean, who goes out and buys a car and doesn't have the ability to check the oil? I mean, who still likes to open up the hood and check the oil? I mean, I have the gauge. Why don't I just trust the oil gauge? Oh, that's fine. I never need to check my oil. I believe it. Sometimes I use, I'll say a span port. It's like the gauge. Yeah, you're seeing some good information, but isn't it nice to open up the hood and I actually want to see, what's the oil level? I want to see everything available. I want to see all the data on my network. So it's really moving more into, starting to look at monitoring your network, from day one. And, shouldn't you start looking at taking your network from day one and providing access, not just for Wireshark, but for any tool that you have that you need to deploy within your environment. And, maybe some of your tools are temporary. Maybe you only want to look at a certain length for an hour, for a day, for a week. But then you have your intrusion detection system that, you're not going to say, I'm only going to run intrusion detection on Monday. I'm going to run Wireshark on Tuesday. That's a permanent placement device. So you need to permanently have access to your network to be able to capture all the data that you need. So when you're building a network, what do you want to look at? You want to be able to provide access. You want to make sure that all the traffic on your network's going to your network tools that you're utilizing. You want to make sure that you're not introducing latency to your network. So you want to make sure that if you're putting devices in line that you're actually, isn't going to be a problem. You don't want to put a failure point in. You put a hub into your network, and let's say you have a T1 going in a remote site. So you say, I'm going to throw a hub at all my remote sites. So if there's ever a problem, I can just go up with my laptop, plug in, and get access. But the problem is, what if that hub fails? Now your WAN connection goes down. So again, it's important that if you're looking to gain access, that you make sure that you're not putting in a failure point in your network. You want to make sure whatever you put in there isn't going to cause that network link, to go down where you have outages and your network's down. So it's so any questions or comments or is there anything? I know a couple people said they use taps. Yes.
So if I want to monitor all the traffic from my server, I have to physically disconnect them if I want to use a tap.
Yes. Yeah. The question is if he wants to monitor the traffic. Now, if you start having critical points within your network, you may want to look at making permanent placements. So if there's some critical locations that you want to collect historical data, you want to do captures when everything's running well. So the thing is, it is something that when you first install it, you have to physically disconnect the network. So when you're using it more as a mobile application, and you're carrying one of these around in your laptop, that if you're going to monitor it, when you first install it, you do have to disconnect the one cable and have a second cable in your bag to make the full connection. But that's really, when tapping first started, the whole idea of tapping was really a mobile application. You would take it, put it in your laptop bag, and that's you go solve your problem. So if I have a problem, I'm going to go put it into the network. I'm going to leave your portable, luggable suitcase device that's supposed to be portable and drop it off and come back the next day and see what's going on. what we see, in the marketplace is, we see that the tapping, the whole access piece is really changing. So, it's important that when you're, with your laptop and with Wireshark, that you do have a portable device. But what we're finding is that, people are moving more towards, permanently installing access throughout their enterprise network. So they're moving towards enterprise class solutions where they're actually rack mounting them and, tapping multiple links. And, some of those links they may be sending to tools that are permanently seeing the traffic, and then some of them are temporary. But the idea is that, more companies are looking at access as the start of an infrastructure. So if you're building out a data center, now you're thinking about access and permanent. Now with Wireshark, I really didn't get into, I didn't want to get into today's presentation too much on, how do I build my backbone and make sure I have access for all my tools. I have 6 different tools. A lot of times Wireshark is more of a portable application, but if you do have critical links within your network, it may be something that you want to start looking at is, having a tap in place, hooking it up to a PC where, you're always collecting information. So then now you have the capture, and even if you're just learning Wireshark, now you have the capture, and you can go work with someone, who specializes, like Mike Kanaki said. It'd be great. He would love if every customer had, the tap with a little data collection. He has a script on there that automatically dumps the traffic to the hard drive, and they call up and say, Mike, I have a problem, and he says, oh, email me or give me access. I'll just go grab the capture files and I'll work on it and get back to you. Let's see what the problem is. So, in those critical links that you can't afford to down, you may want to look at putting something permanently in place for that, so you always have access. Are there any? Yes.
One of your bullet points listed secure access points. How do you secure them?
Well, a good example is, especially like in security, let's say you're deploying an intrusion detection system, and you don't want to, you don't want anybody to see the device on the network. With the tap, you're actually, you're physically going in line and providing a copy. Depending on, there's different taps, but if you're getting a passive tap that's physically providing a copy of the traffic, now you're sending that to your intrusion detection system, and there's no way for anybody on that link to ever see. Physically it's impossible. So you're securing your device that you're doing the monitoring with. So a lot of times in security, they don't want, they just want to capture the data and sniff it for intrusion detection. So when we say security, we're talking about providing an inline device and providing a copy of all the traffic, and securing the device that's physically collecting the data. Now a lot of times it's not going to be applicable with Wireshark, when you're collecting information, but it's it's an issue of that you don't want anybody to know that you're watching all the packets. So provides you a copy of all the information, and someone's not going to see that you have an IDS box connected to it. But it would be the same. They're not going to see. And so you want to, you have a teenager, pop one of these in there and just capture all the files, and you'll see every packet flowing back and forth between his PC and the switch at your house. So again, it's all about seeing all the traffic in your network. Any other questions, or does anybody want to come up and take a look? And yes.
There are a couple of vendors that sell those. What is the difference? Or is it all the same?
Yeah, question. There's quite a few vendors out there. There's a couple. I want to say there's a ton of vendors out there, but yeah, there are a couple of vendors that are selling the technology. And some of the differences out there is this is the traditional market right here. The traditional market has always been, in the analyzer market, where you have a portable device that you can take with you and physically go sniff the market. So one of the big things, not to put a plug in there for Network Critical, but one of the things that we've done, we've always come more from the security market. So everything we've done since day one, and when we came out with our first products in 1999, is that everything we focused on was more permanently placed. So it was all chassis-based solutions, carrier class, proper internal power supplies, meant to be permanently placed there. Not only can you tap a single link, you can tap multiple links. So now people are looking at, they're not just buying one for their notebook, but they're buying, they're saying that I need to physically tap 50 links in this one particular data center. Now you take you take one of these devices here, and now think about taking a rack mount plate. You put 3 of these in a rack mount plate. You have 2 power supplies per device, 2 times 50. Now you need 100 plugs in your rack. That's a nightmare. So one of the big things is that now that people are really starting to instrument their network with access, is that really looking at providing true data center class products. Some other differences is looking at full traffic. If you're physically tapping a link, as I mentioned, a network tap, a standard breakout tap, gives you the transmit and the receive, or it gives you if it's A and B, C shows you A, and D shows you the B traffic, right? So you're physically having the 2 sets of traffic. When you aggregate the traffic, you physically combine it to your Wireshark notebook. If you're tapping a 100 megabit link, and I give you an aggregated port of a gigabit, you're never going to drop a packet. But let's say you physically tap a gigabit link, and it's running full duplex, and it's 100% utilization. Now you have 2 gigs of traffic, and you're going to aggregate it to a 1 gigabit port. Well, guess what's going to happen? You're going to start dropping packets with the aggregating tap. So when we designed our aggregating taps, we said, well, that's unacceptable. You can't sell someone a tap that's going to drop packets. So when you buy the tap, let's say day 1, your network utilization is you're running 200 megs of traffic. 2 years from now, you're doing all these video applications, and you've changed your business, and you're doing gaming and whatever else. So now you're running at 1.5 gigabit on your link. Now you just reconfigure this tap, and you say, I want this port to be, now I want it to be a breakout tap. So, one of the differences out there to really look for with the different technology is, can you reconfigure it? So if I'm buying an aggregating tap, can I reconfigure it to a breakout tap? Because, why do you want to buy something that you can't reconfigure? So those are some of the things as, looking at if you're going to, really outsource your whole network, and you're really going to start, we get server farms for compliancy. People will, install 50 or 100 of these things in their server farms. And, they're looking for proper, chassis-based solutions. And also, one thing that I like to talk about real quickly, and is an important thing, is the word passive and tapping. This can be marketed in different ways. And with 10100 networks, you can physically tap a 10100 network, and it can be truly 100% passive. And what do I mean by that? I mean that if you I physically unplug, plug back in, unplug, 0 interruption on the network. Fiber optics, if you do an all optical tap, you can purchase optical taps that will be 0 interruption. You can get an optical tap that has no power to it. So when you pull the power out of it, there's no power, so there's no interruption. You don't have to worry about it. Now with copper gigabit, that's a different animal. When you're dealing with copper gigabit, every endpoint within the link has to negotiate. So what happens is, if this happens to be a 10100, if you're using a gigabit, you tap a gigabit link, and power is lost to this device, that link will physically drop and then reestablish. So one of the things you want to look at there is, if you're looking at different copper gigabit taps in the marketplace, is test which ones fail over very quickly. Make sure it happens quickly, and it's reliable, and you're not going to run into issues with that. But with copper gigabit, there's no way to have a truly 100% passive device. That word gets thrown a lot, and we generally, the way we call this fail-safe technology. And the reason it's fail-safe is, if you were to pull the plug on it, it drops, and then your link reestablishes. So, those are some of the things you want to look at in the marketplace. And, when you start talking about losing power, when you start getting into proper chassis solutions, the power issue generally doesn't become too much of a power issue. You kind of got two power supplies, set them up to different UPSs, to your generators or whatever's in your data center. So now if power's lost to the tap, I guarantee you're not going to be calling me, because your whole data center probably has a really big problem. So those are some of the things that you want to look for when you're looking to purchase a network tap. Any other questions?